Good day, everyone. I'm Sir RG Layson, your math tutor and guide on this exciting journey through the world of numbers. In this video, we will discuss all about English language versus mathematical language. Now, before we proceed to our main lesson for today, let's have an activity first. Please select one of the following question and answer in a few minutes. You can pause the video and try to translate the given questions here. First, we have in Arabic form or in Arabic language. Second, in Greek language. And third, in the French language. Now, the question is, did you spend enough time and thought really hard trying to understand the question and thinking what to answer? Yes. So, it's really hard to translate that one because it's in the foreign language, right? So the question were intentionally given in a foreign language, but they actually mean the same thing, and that was, what are your expectations in this course? What were your first thoughts after seeing the question in foreign language? Surely, it's hard to translate, right? But then, if the question was given in English, Filipino, or Visaya, you can answer it directly, right? Yes. Some people have trouble understanding mathematical ideas, not necessarily because the ideas are difficult, but because they lack of knowledge of the language in which the ideas were presented, or specifically even in the simplest context of math class. The ideas are being presented in the foreign language, in this case, the language of mathematics. In the nature of mathematics as a language, they say that mathematics is a universal language. Why is it mathematics is a universal language? Mathematics is the same all over the world. A phrase or a formula has the same meaning regardless of another language that accompanies it. So, if you try to ask a Filipino, or if you are here living in the Philippines, you try to ask a person, 2 plus 2 will always equals to 4, right? And if you go to Europe countries like Italy or UK, everyone you will ask someone there, or anyone you would like to ask there, 2 plus 2, they will answer it directly as 4, right? Even pi is always approximately 3.14. Even people living in the Antarctica place, where is the coldest area in the world, right? The people will answer it, 3.14 is the approximate value of pi. No matter what country you are in, the mathematics is the same all over the world. Math is the only language that is shared by all civilizations regardless of culture. No? Even here in Caraga, for example, Manuba culture, Butuanan culture, and Surigao culture, math is always the same. Okay, if you, for example, if you'll ask someone who is a Butuanan, you will ask 2 times 2. The answer will be 4. And even in you go to Surigao City, the people there are Surigaonan, right? So anyone you would like to ask there 2 times 2, their answer will always be 4, because it's it is also inculcate na sa atong mind that the context, the basic concepts of math is already there. Even in religion, Catholic people, born again Christians, math is the same. Nothing changed. Even in gender, so male, female, or other genders like LGBTQ plus, it's the same. Math is always the same. Anything that studies interaction between quantities involves numbers, variables, structures, and change is mathematics. You need to take note of that. No, we've already discussed this one. This quote by Galileo Galilei, mathematics is the language in which God has written the universe. Even in the Bible, even in the Genesis chapter, God already stated there the sequence in numbers, right? First day, second day, third day, fourth day, fifth day, sixth day, seventh day. Even he said there in these chapters that go to the world and multiply. The concept of math is already there. Just like any other language, it has its own vocabulary, grammar, set of rules, range and meanings, and community of people using it. This requires more than just knowing the words and sentence are. For something to be considered as language, it should contain the following essential components displayed in the first column in the table and have this possessed by mathematics in the second column. So they say that language has to have vocabulary of words and symbols. Now, mathematics has formed from different alphabets and symbols. Expressions from one or more combinations of the following. We say Arabic numerals. Arabic numerals, we can consider there counting numbers, natural numbers, and even integers, right? In fractions, so we have here represented by our symbols and words in math. Variables, so in finding the unknown numbers or unknown values, we can represent this one. So we have here a common example is finding the missing value of x, finding the missing value of y, or finding the missing value of z. Expressions. So expressions are combination of numerical coefficient and a variable. So we have here an example. 3x, x squared, 4 plus x. Diagrams are visual elements such as circles, angles, triangles, and matrices. Even infinity numbers. So we have also there our own vocabulary of word in math and even symbols. Imaginary numbers, the speed of light. Now, in language has to have meaning attached to words and symbols. Now, mathematics has usually in real world problem or real world problem class, we always encounter real world phenomena or abstract concepts, right? So that is mathematics has. A language employs grammars, which is set of rules that outline how vocabulary is used. So from math, so we always read math from left to right, right? For example, so we have a given equation 3x plus y equals to 10. So we start reading the given equation 3x from left plus y equals to 10 to right. Okay, so we have also set of what do you call that, rules in simplifying numbers. The common is PEMDAS. Before we simplify the numbers, we need to follow PEMDAS. Parentheses, simplify the terms in parentheses, simplify the exponents, multiplication or division, and after that, addition and subtraction. In Latin alphabet is used in parameters and variables. So some of this are in integers we use I, J, K, L, M, N. In real numbers we use A, B, C, alpha, beta. Complex numbers are indicated by W and Z. And unknown numbers are Y, X, Y, and Z. And name functions are usually used F, G, and H. Parentheses and brackets indicates the order in which the symbols interact. The way functions, integrals, and even derivatives are phrased in uniform. Now, the language has to have, there must be a group of people who use and understand the symbols. Now, mathematics has many mathematicians and even scientists all over the world who is trying to understand deeper and deeper about the math concepts. So concluding statement, mathematics is a universal language with own set of vocabularies, with own set of rules, with own set of systems of communication, which requires more than just knowing what words and sentence are. It requires understanding of meaning of words and symbols, organization, rules, and conventions. Now, we need to recall that English language noun, a noun is a word that used to identify any of the class of people, names, for example, places or things, or to name a particular one of this, while the sentence refers to a set word that incomplete in itself. Normally, it is answered by yes or no, by typically containing subject and predicate. In this section, we study the counterparts of the words of mathematical language. So let's have define the expression and sentence, or the mathematical sentence and mathematical expression. An expression is the mathematical analog of English noun. It is correct to arrange the mathematical symbols used to represent the mathematical object of interest. An expression does not state a complete thought. In particular, it does not take sense to ask if the expression is true or false. So, for example, we have here in English noun, let's say Juan. Juan is a name of a person, right? That is an English noun. Now, in mathematical expression, we have an example there, 3x, for example. 3x does not state a complete thought. We can't find the value of x there. We're just stating 3x. That is an example of mathematical expression. Now, in a mathematical sentence is an analog of English sentence. It is correct to arrange the correct arrangement of mathematical symbols that states a complete thought. That means it can be answered by true or false, for example. For example, we have here, uh, the boy is handsome. Yes, that is an example of English sentence, which can be answered by true or false. For a mathematical sentence, we have 3x plus 5 equals to 10. Now, since we have here a symbol there and an expression there present, so that means it can be answered. We can already find the value of x there by simplifying it, and now we can say that the statement or the mathematical sentence can be true or false. Moreover, if English language has nouns, verbs, connectives, expressions, and sentence and conventions, mathematics language also has, we have here. Now, name given to an object of interest. So we have here noun. A person, example, Juan. Place, Butuan City. Thing, book. In mathematics, we have expressions, for example, 5, 2 plus 3, x plus 1/2. So we have here, the examples here are examples that are not complete thought, or it cannot be answered by true or false. While a complete thought, for example, in English sentence, the capital of Caraga is Butuan City. That is true. So that means it is considered to be English sentence. CSU is in Bayugan City. That is false. But then, it is an English sentence because it consists of complete thought. In mathematical expression, we have an example, 3 plus 4 equals to 7. Is 3 plus 4 equals to 7? Yes, that is true. And we have here y plus square root of 3 equals 18. Since we have here an expression, present of expression, present of symbol there, now we can say we can find the value of where the y there by simplifying it. Now in verb, in English sentence, or in English, in word or in English, is, and in mathematics it represents equal sign. Connectives and or are represents addition or plus sign. Let's try to answer this one. Clarify the entries in the list below as an English noun, mathematical expression, a mathematical sentence, or a English sentence, or a mathematical sentence. We have here number 1, infinity. That is an English noun. Mathematics is a universal language. We can answer that one as true or false. So that means that is an English sentence. We have number 3, x squared plus 10x plus 20 equals to 10. We have a given expression and a symbol equal sign. That is a mathematical sentence. We can find the value of x there. We have x plus 6 raised to 2 minus 15 equals to 5. That is also a mathematical sentence, since it is a complete thought class. So next example, last example, we have 3x squared. That is a mathematical expression, since it is not complete or not a complete thought. There are some similarities about English language and mathematical language. Consider the mathematical sentence 3 plus 4 equals to 7. 3 plus 4 is equal to 7. It is easy to determine that the equal sign is the verb there. In fact, that is the most popular mathematical verb. Other verbs and symbols we have here less than, is less than, or in other term is below, is smaller than, and while we have greater than, is above, is more than, less than or equal, is at most, is not exceed, is maximum. Greater than or equal to, is at least, is minimum, and not equal is not equal. Now in this given class, so we have here the symbol is an equality sign. The other symbols less than, greater than, less than or equal, greater than, equal, and not equal is considered to be an inequality symbols. Now later on in our next lessons, we will discuss there in linear inequalities in two variables. We will tackling all the symbols, and then after that, no, we just need to simplify the given mathematical sentence there, and after that we will check if it is a true a solution by checking it if it is true or false. Now the constant terms are nouns, so we have here an example 3 4 7. So same with nouns, so it's just not a complete thought. And 2x minus 5 is an expression, while 5 minus 2 equals to 12, and 2w minus 3, a square root of 2w minus 3 is equals to w, are sentence which can either be classified as true or false, depending what are the values of y and w. And the symbols and, or, and implies are example of connectives. Now in logic of mathematics class, or in the truth table, when we simplify mga truth table values, no, we will going to use the symbols in our next lessons. Now let's try to translate this one. So number one, we have the sum of 5 peso coin and 10 peso coin is greater than 45 pesos. Which letter can be translated mathematical sentence based on the English sentence. So we have here letter E. 5f plus 10t greater than 45. Next, the difference between the height of Mark and Rhea is at least 5. So we have letter C. M minus R greater than or equal to 5. 3 years more than twice the age of Kian is less than the age of his father. So we have here 2k plus 3 less than f. Next, in a week, Martinez family spends at most 3,000 pesos for food and education expenses. That is letter F. F plus E less than or equal to 3,000. Next, twice the number of green balls is less than the number of yellow balls. That is letter A. 2G less than Y. The differences between English language and mathematical language. Unlike English, mathematics does not have emotional context and does not use to represent the past, future tense. So mathematical sentence always use present tense. Is, in a form is. Is example, x plus 2 is equal to 8. Ordinary speeches is full of ambiguities and full of unspoken culture assumption. So for example, here we have look at the dog with one eye. Could either mean look at the dog using only of your one eye, of your eyes, one of your eyes, or look at the dog that has only one eye. So another example in English language, turn left. I didn't hear you. Left, right. So there is an emotion out of it. Or unpredictable pattern, for example, woman, plural for women, man, plural for men, and pants is plural, the plural form for that is pants. On the other hand, mathematics is expressed itself at utmost clarity or and an ambiguity. This feature distinguishes it from all other language. For example, in the sentence 2x plus 4 is equals to 6, the only value of x, or the only solution for the given equation, is equal to 1. That could make the sentence true. And the all other values of x will make it false. So we need to understand that mathematics is in utmost clarity. When dealing with sequence in mathematics, one can clearly and definitely predict the succeeding entries as patterns in mathematics are an ambiguous say. For example, 135, one can certainly tell that the next number in the sequence is 7. We can predict now because their common difference based on the given three values there, 1, 3, and 5, their common difference is 2. So that means we can predict that the next term is 7, next term is 9, next term 11, next. Let's end this slide by having a quote by Peter Hilton. Mathematics cannot be learned without being understood. It is not a matter of formulas being committed to memory, but of acquiring a capacity for systematic thought. Thank you for watching. That's all for today. I hope that you've learned something out of this lesson. Please don't forget to like and subscribe and share it with your friends. Thank you so much, everyone. Goodbye.